Okay, for Chapter 3, Lesson 1, we go to beams. Beams are used extensively in structures, primarily in flooring systems for buildings and bridges. They belong to the line element category. So their longitudinal dimensions is large in comparison to their cross-sectional dimensions. Now, dun sa truss kasi, ang kino-consider natin is axial loadings. Pero pagdating sa beams, we are usually considering normal loads or yung mga loads that are perpendicular to the beam itself. So, there are two parameters we are considering in beams. We have the shear force and the bending moment. So, ano ba yung shear force? Ano ang bending moment? Let's have this example. And so, for this example, di ba, yung dito sa may point A, andito yung isang support, tsaka yung point G, nandyan yung isang support. So, if I take summation of moments at G, ma-eliminate si VG, I can solve for VA. So, VA is equal to 10 and VG is also equal to 10 kilonewtons. So, again, you need to be familiar with the static equations to solve for that reactions. Now, dito sa may page 2 to page 3 ng notes ninyo, diniscuss dito yung, kumbaga yung long method on how to determine the shear forces and the bending moments for a certain beam. For example, sa figure na to, if I'm going to take the shear at point C, so ikakat ko ngayon dito sa may between point C to D, kaya ito yung figure na to. So, kapag kinat ko siya doon, may bending moment between C to D. So, from that, magkakaroon tayo ng mga equations. Diyan yung equations na yun, makukuha natin yung 10.2, that is the moment at itong value ng M na to. Same through with the other sections of the beam. Now, masyadong mahaba kapag i-discuss ko sa inyo yung pagkuha ng mga moment equations. I just want to discuss with you yung ginagamit namin or ginagamit usually to shorten the time at saka yung paggamit ng masyadong maraming equations. I'm going to discuss with you the properties of your shear and moment diagrams to draw the shear and moment without using any equations or without writing yung mahabang mga equations. Now, for the properties of shear and moment diagrams, you have to take note of this. The area of the shear diagram to the left or to the right of the section is equal to the moment at that section. The slope of the moment diagram at a given point is the shear at that point. The slope of the shear diagram at a given point equals the load at that point. The maximum moment occurs at the point 0 of zero shears. This is in reference to property number 2, that when the shear is 0, the tangent drawn to the moment drawn is horizontal. Now, ang gusto ko lang na i-point out is properties 1 to 4. Properties 5 to 6, madali na lang to. In illustrative problem number 1, 60 kilonewton concentrated loads is applied at point A. Uniformly distributed naman kay B to C and moment kay point D. Now, you're required to draw the shear and moment diagrams. But before tayong ma-draw yung shear and moment, kailangan nating isolve yung mga reactions. So, if I take summation of moments at point E, clockwise positive. Itong si 60, pag nag-moment at point E, clockwise yun, kaya negative. And the distance of 60 hanggang kay point E is 6 meters. RB is, kapag magmo-moment kay point E, ay clockwise, kaya positive. Distance ni RB hanggang kay E is 5 meters. Ito namang uniformly distributed load na ito. Kapag mapapansin ninyo, ano itong 40 times 3? this 40 times 3, that is the area of this uniformly distributed load. Multiplied by the distance. Kapag nakuha nyo na yung area nitong uniformly distributed load, ang makukuha ninyo is the resultant. Ito yung ngayon yung 40 times 3, itong kulay red na arrow na ito. Now, yung distance nitong resultant na to hanggang kay point E is 1/2 of this 3, that is 1.5, plus itong 1 and 1, kaya 2. Nagkaintindihan tayo doon? Ulitin ko, kapag uniformly distributed load, all you have to do is to take the area of that distributed load at yung magiging distance niya is yung kung saan yung resultant or yung centroid hanggang dun sa my point na kino-consider ninyo. And since this is a moment, hindi niya na kailangan ng moment arm kasi moment na to. And here is our notation. Kapag clockwise, ang direction ng moment positive. Kapag naman counterclockwise, negative. Kaya since this is a clockwise moment, plus 120. Nagkaintindihan tayo? So here now, my RB is equal to 132 kilonewtons and pataas siya. If I take summation of forces along the y-axis, again upwards positive, that is, kung mapapansin ninyo dito, itong 60 na to, ito siya, pababa kaya minus. Ngayon, itong uniformly distributed load na ito, ang direction niya is pababa. Again, all you have to do is to take the area of that uniformly distributed load, that is 40 times 3, negative siya kasi yung direction ng arrow pababa. While hindi ko na kinonsider itong 120 na to kasi hindi siya force na pababa, that is a moment. So, inputting this in my calculator, RE now is equal to 48 kilonewtons upward. So, in this case now, my RB is equal to 132 and my RE is equal to 48 kilonewtons. To draw now my shear and moment diagram, hindi ko gagawin yung long cut kasi masyadong mahaba siya. So, I'm going to show to you yung diretsong pag-drawing ng shear and moment diagrams. So, in here, kung mapapansin ninyo dito, ang shear kay point A is negative 60. Paano ko nakuha sa negative 60? Kung mapapansin ninyo, itong arrow na to, itong 60 kilonewtons na to is pointing downwards. So, in that case, since concentrated siya, ang gagawin ko ngayon, ide-diretso ko lang siya. So, that is a straight line. Since pababa yung direction, that is along negative 60 kilonewtons. Then, kung mapapansin nyo, from A to B, walang load doon. Walang applied na load. So, since walang applied na load, all I have to do is to draw a straight line. Now, at point B, the shear at point B is equal to 72 kilonewtons. Paano ko nakuha si 72 kilonewtons? Diba nag-end tayo kay 60 kilonewtons? So, kapag nag-end tayo kay negative 60 kilonewtons, mapapansin ninyo, nandito si RB, 132 kilonewtons. Ang direction ni RB is upwards. So, ang upward natin is positive. Nag-end tayo kay 60. Now, to determine VB, negative 60, since upward si 132, so I have to add 132 kilonewtons, and that is equal to 72 kilonewtons. Since upward siya, so mag-drawing lang ako ng line to connect negative 60 and 72 kilonewtons. Okay? Next, punta tayo kay shear at point C. Shear at point C. Nag-end ako kay 72. Itong 40 kilonewton per meter, this is a uniformly distributed load and pababa siya. Since ang direction ni arrow is pababa, so minus. Kukunin ko ngayon yung area nitong uniformly distributed load. That is 40 times 3. Nag-end ako kay 72. Ngayon kay VC, I'll start with 72 kilonewtons minus 40 times 3, that is equal to negative 48 kilonewtons. Negative 48 kilonewtons. Now, ang question dito, paano ko ngayon i-connect si 72 at saka si negative 48? Will that be a straight line? Will that be an inclined line? Also, anong magiging basis ko dito? Kapag ang slope or ang itsura ng ating load ay straight line, that is considered to be a 0-degree curve. So kapag dito sa may load diagram, 0 degree siya. Pagdating naman ngayon dito sa may shear diagram, yung magiging degree of curvature na is 1. So nag-start tayo dito ng 0. Pagdating ngayon dito kay shear diagram is magiging 1 degree curve. Ang itsura ng 1 degree curve ay slanting line. So, ang ibig sabihin ngayon nun, i-connect ko si 72 at saka si 48 kilonewtons using a slant or diagonal line. Nag-start tayo kay load diagram ng 0 degree. Pagdating kay shear, magiging 1 degree curve. Okay? Next, from C to D, walang load na na-apply yung moment lang na 120, but disregarded pagdating sa shear. Again, sa shear, ang kino-consider natin is yung loads na pababa or pataas lang. Pag beam. From C to D, wala nang load. So, all I have to do now again is to draw a straight line. So, pagdating doon, 48 kilonewtons pa rin. Hanggang kay E. Kasi walang load along the y-axis. Now, doon naman kay shear at point E, nag-end ako kay negative 48. Then, kay E, may pataas na 48 kilonewtons. So, all I have to do now is negative 48 plus 48, that is equal to 0. So, ganito yung magiging itsura ng aking shear diagram. As you can see, nag-start ako kay 0. Then, I ended at 0. Kapag nag-drawing kayo ng shear diagram, nag-start kayo ng 0, pero pagdating sa end, hindi siya nag-0, there is something wrong with your computations. Pag na-drawing na natin si shear diagram, we can now draw the moment diagram. But before we can draw the moment diagram, mapapansin ninyo, nag-0 dito sa point na to. So, I need that distance. Again, let's use our favorite variable, x. Let that distance be x, and the other side is 3 minus x. Now, pag we need to solve for x, paano? Using the ratio and proportion, yung triangle na ito, tsaka yung triangle na to, similar triangles, my x is equal to 1.8 meters. Kapag nakuha ko na ngayon si x, yung value ng x, I can draw now my moment diagram. Now, the relationship between shear and moment, ang sabi doon, the moment is equal to the area of your shear diagram. What do I mean by that? Now, if we take the moment from point A to point B, that is equal to the area. Kung mapapansin ninyo, ito yung point A, ito yung point B. Yung shear doon ay itong rectangle na to. Right? Now, if I'm going to get the area of this, that is equal to 60 times 1. Ano yung 1 na to? That is the distance from point A to point B. Right? So, that is negative 60 kilonewton meter, yung moment kay point A to B. So, if I'm going to plot that one, ngayon yung magiging itsura. Paano ko nasabi na slanting siya? Diba sabi natin kanina? Kapag straight yung line, that is a 0 degree curve. Again, sa shear, this is 0. Pagdating ngayon kay moment, magiging 1 degree. At ang itsura ng 1 degree curve natin ay slanting or diagonal line. Okay? Next, punta na tayo kay point B to C prime. This C prime is itong location ng ating point of inflection, or itong nag-0 na to. That will be our C prime. So again, nag-end ako kay 60 kilonewton meter. This time, itong area between point B to C prime is a triangle. This is a triangle. Ang area ng triangle ay 1/2 base times height. Itong 1.8, that is the base of my triangle. 72, that is the height of my triangle. So, ang magiging moment ko from point B to C prime is 4.8 kilonewtons. Now, itong, di ba, diagonal line na to. So, this is a 1 degree curve. Pagdating ngayon kay moment diagram, magiging 2 degree curve na siya. So, hindi na siya diagonal or straight line. So, dapat yan magiging curve. Ano ngayon magiging itsura ng curve? Dito ngayon, ipapasok ko yung diagram na to. What do this diagram stand for? Or paano gamitin tong diagram na to? Diba, second degree curve na ngayon pagdating kay moment diagram. So, paano magiging itsura ng curve ko? Is that a concave downwards or a concave upward? Now, in using this diagram, ganito lang siya. Kung mapapansin ninyo dito sa may shear diagram, itong triangle na to, nasa taas. Kapag yung shear nasa taas nung line, that is considered to be positive. Positive siya. But this is 72 kilonewtons. Then, nag-zero out siya. So, from 72 to 0, nag-decrease. So, that is a positive decreasing. Ay, di ba, 72. Then, nag-zero siya. So, from 72 to 0, that is decreasing. And since nasa taas, that is positive, andito siya ngayon. Anong magiging itsura ng curve? Ito. Okay, that is concave downwards. So, kapag concave downwards, ganyan yung magiging itsura ng curve ko. Ay, isa pa. From point C prime to C. Again, nag-end ako kay 4.8. I'll start with 4.8. And since yung triangle natin, itong point na to is nasa baba, so that is negative. And the area of this triangle is 1/2. My base is this one, 3 minus x. And my height is 48. Now, in putting that in my calculator, that is negative 24. Again, this is a 1 degree curve yung nasa shear. Pagdating kay moment, that is a 2 degree curve. Now, I'm going again to use this diagram. In using this diagram, kung mapapansin ninyo kay shear, from 0, pumunta siya kay 48. So, that is increasing. I. From 0 to 48, that is increasing. But since nasa baba siya, so that is negative. Anong magiging itsura ng curve ko pag negative increasing? That is concave downwards. Kaya yung magiging itsura ngayon ng curve ko is like that. Nagkaintindihan tayo sa paggamit ng curve. Okay? Next. From C to D. Nag-end ako kay 24. Now, as you can see here, from C to D, this is a rectangle. And the area of a rectangle is 48 times 1. Ano tong 1 na to? That is the distance from C to D. So, that is equal to negative 72. Negative 72. Paano ko i-connect si 24 tsaka si 72? Diba, dito kay shear kasi, that is a straight line. Again, that is a 0 degree curve. Pagdating kay moment, magiging 1 degree curve. Ang itsura ng ating 1 degree curve is a slanting line. Okay? Now, dito kay point C, mayroon tayo dito yung moment na 122. So, if I'm going to take the moment at point D, that is equal to negative 72 plus 120, that is equal to 48. Since moment yon that is clockwise. Pag clockwise kasi positive natin, so pataas lang siya, magdodrawing na ako ng straight line. Again, from D to E, that is, nag-end ako kay 48. I'll start with 48. And this is again a rectangle. Since nasa baba siya, minus 48 times 1. So, ang moment ko now kay D to E is 0. Ay na, observe ulit ninyo, nag-start ako kay 0, mag-e-end ako kay 0. As usual, kapag nag-start kayo kay 0, pero at the end, hindi kayo nag-0, again, you have to do your computations. There is something wrong with your computation. For illustrative problem number 2, this is a combination of concentrated load and ununiform distributed load. And kung mapapansin ninyo dito kay point B, yung kulay red na to, that is an internal hinge. So, kung kukunin natin yung degree of indeterminacy nito, because of this internal hinge, magiging determinate structure ngayon itong beam na to. So, we can solve the reactions. Now, paano natin isosolve yung reactions nito? First thing we have to do is ihiwalay natin yung internal hinge. So, in this case, I'm going to consider AB. Kasi yung point B, nandun yung internal hinge, kaya ihihiwalay ko siya. Now, looking at this beam AB, may hinge kay point A, kaya mayroon akong RAX at saka RAY. Then, may VB ako. Now, if I'm going to use some summation of moments at point A, clockwise positive, pag nag-moment si VB kay point A, that is counterclockwise. Then, 5, that is the distance of VB hanggang kay A. Now, dito ngayon sa may pagkuha ng resultant nitong load na ito, itong triangle na to, you have to take the area of that. Since that is a triangle, the area of a triangle is 1/2 base times height. Kaya itong kulay green na ito. That is 1/2. My base is 5 and the height of this load is 24 kilonewtons. Itong kulay green na to, that is the resultant of this load. Itong triangle na load na to. So, kung idodrawing ko yung resultant ko, andito siya. At this point. Now, itong 2/3 of 5, that is yung location ng resultant. Diba yung area ng force na ito, yung 1/2 5 times 4, ito yun, itong kulay red na to. Now, itong distance from here hanggang kay point A, diba pag nag-drawing tayo ng triangle, andito yung centroid. Yung centroid na yun, that is, from your geometry, this is 1/3 of, let's say, this is length of your triangle. So, itong distance na to, this is 1/3 of your length. Now, the remaining, dito hanggang dun kay may centroid, this is your 2/3 of L. Right? Dun ko nakuha si 2/3. Okay? Then, pag nakuha ko na yung ito, the VB now is equal to 40 kilonewtons, and that is upward. Summation of forces along the y-axis, RAY, that is upwards, minus, again, take the area of this load. That is 1/2 of my base times height. My RAY now is equal to 20 kilonewtons. Now, if I take the summation of forces along the x-axis, 0 ang value ngayon ni RAX. So, kapag nakuha ko na yung reaction at point A at saka yung reaction dun sa may internal hinge. I can continue. Wherein, punta na ako kay segment B, C, D, E, F. Diba kay B, andito yung internal hinge and nasolve ko yung VB is equal to 40 kilonewtons. Now, doon, kapag babalikan ko, dito kay VB, that is 40 kilonewtons, pataas siya. Pero, once na pumunta na siya kay B, C, D, E, F, yung pataas na 40 kilonewtons, magiging pababa ngayon pag pumunta na siya kay B, C, D, E, F. Then, taking summation of moments at point C, walang problema dito kasi puro concentrated loads. My RF is equal to 35 kilonewtons. And summation of forces along the y-axis, my RC is equal to 110 kilonewtons. So, nasolve ko na yung mga reactions ko. Ang reaction ko kay point A is 20. Ang reaction ko kay point C is 110. And the reaction at point F is 35 kilonewton. Okay? Now, I can now draw my shear diagram. Now, in my shear diagram, gaya ng ginawa natin in the previous slides, pataas si 20 dito. So, all I have to do now is to draw a straight line. Pataas, so positive 20. Next, ang shear ko from point A to point B. Now, I'm not going to show to you again paano ko nakuha to. From point A to point B. Di ba nag-end ako sa 20? So, para makuha ko yung shear dito, this is a triangle. So, again, anong area ng triangle? 1/2. My base here is 5. And the height of this triangle is 24. Now, this is equal to times 5 times 24. That is equal to 60. Now, nag-end ako kay 20. Since pababa yung arrow kasi dito, so that is minus. So, 20 minus 60 is 40. Negative 40. Paano ko nakuha ulit si negative 40? That is 20 minus 60. Next, i-connect ko ngayon si 20 tsaka si 40. But since dito sa may load diagram, this is a 1 degree curve, pag nagpunta ngayon dito kay shear diagram, magiging 2 degree curve. Kailangan ko na ngayon itong diagram ko na to. Now, dito sa may load diagram, from 0 to 24. So, that is increasing. Increasing. Pero, dalawang pagpipilian ko, positive or negative. Di ba yung direction ng arrow is pababa. So, that is negative increasing. Kapag negative increasing, ang magiging itsura ngayon ng curve ko is concave downwards. Ayan siya. Okay? Next, walang load from B to C. So, kapag walang load, again, just draw a straight line. Then, dito ngayon, kay C, nag-end ako kay negative 40, may pataas na 110. So, negative 40 minus 110 is equal to 70 kilonewtons. Okay? Next, from C to D, walang load ulit. Again, kapag walang load doon, straight line. Then, nag-end ako kay 70. At point D, may pababa na 45. So, 70 minus 45 is 25. Again, that is a straight line. From D to E, walang load. So, straight line ulit. Then, nag-end ako kay 25. May pababa na 60. So, 25 minus 60, that is negative 35. From E to F, walang load. So, straight line. Nag-end ako kay negative 35. May pataas na 35. So, negative 35 plus 35 is equal to 0. So, ganyan yung magiging itsura ng shear diagram. After na na-drawing ko yung shear diagram, kung mapapansin ninyo, meron akong X dito. Yung X na yon is the distance between the point A hanggang kay may point G. Kasi kay point G, nag-zero doon yung shear. Now, I need this distance X para ma-drawing ko si moment diagram. Paano ko ngayon ikukunin yung X? Now, using again, ratio and proportion, mag-ratio and proportion ako using a triangle. At ang nakikita ko lang na triangle dito na pwede kong gamitin ay yung nandito sa may load diagram. So, if I'm going to use that, 24/5 is equal to y over x. Ano yung 24? Ano yung 5? Okay. Since nag-0 dito kay my point G, now if I'm going to extend that up to the load diagram, andito yung may y. So, again, using ratio and proportion, this bigger triangle is equal to the small triangle. So, 24/5 is equal to y over x. My y now is equal to 4.8x. After that, at point G, the shear is equal to 0. So, kapag kukunin ko yung shear kay G, that is 20 minus, bakit minus? Kasi pababa yung direction dito sa may load diagram. Minus the area of the load diagram. So, 20 minus, yung area nitong small triangle na to is 1/2. My base is x, and my height is yung y. Therefore, now, the value of my x is equal to 2.89 meters. Okay? Pag nakuha ko na ngayon si 2.89 meters, pwede na akong mag-drawing ng shear diagram. Ng moment diagram. Di ba, dun sa previous slides, na-drawing natin yung moment diagram kasi alam natin yung area dito sa may shear diagram. Wala akong problema sa area nito. Rectangle ito, rectangle din, rectangle, rectangle. But, dito ako makakaproblema. Itong part na to. Kasi this is not a quarter circle. This is not also a semicircle. Hindi rin naman ito sector. Now, I would like to introduce to you yung tinatawag nating spandrel. Okay. A spandrel, the area of a spandrel, as discussed during your geometry, that is equal to base times height over n plus 1. Ano yung n? Itong n na to, that is the degree of your curvature. Pansinin niyo ang spandrel ay itong part na to. Okay? So, kung titignan ko, itong shear diagram ko, itong part na to, ang spandrel dyan ay, ito yung spandrel. Yan ang spandrel. Ang kailangan ko dito, yung area na to, again, I'll name this area 1, and I'll name this area 2. So, I need the concept of spandrel to determine the area of my shear diagram. So, if I'm going to explode itong part lang na to, it will look like this. Okay. Andito si 20 kN, andun si negative 40 ito. So, yung spandrel, itong nakakulay gray. Diba, nasolve na natin kanina yung x, that is equal to 2.89. So, the other side is 2.11. Now, ang kailangan ko dito, sabi ko kanina, is the value of my area 1 and the value of my area 2. So, paano ako masosolve ngayon si area 1 at saka si area 2? Let me erase this first. For area 1, itong area 1 na to, that is, pwede ko rin sabihin, this is also a spandrel. Itong part na to, spandrel siya. And the area of a spandrel is base times height. My base is 2.89. The height of this spandrel is 20. Divide it by n plus 1. Bakit 3? Ang n natin dito is 2 degrees. Okay, this is a 2-degree curve. So, 2 plus 1 is 3. Hindi ito yung kailangan kong area. Yung kailangan kong area, itong area 1. So, ang ginawa ko dito, itong rectangle na to, 20 times 2.89 minus the area of this spandrel. So, the value of my A1 is 38.5. Now, for area 2. For area 2, ganito naman yung ginawa ko. Diba, itong buong to is spandrel, yung naka-gray kanina. Kaya ang kailangan ko lang area 2. So, ang ginawa ko dito, yung area ng buong spandrel. Area ng buong spandrel, base, 2.89 plus 2.11 is 5. Times the height of my spandrel. Again, this is my, dito yung 0, yung line ko kanina for the shear. So, 0 ito. 20 ito. 40 dito. So, 20 plus 40 is 60. So, base times height, 5 times 60 divided by n plus 1. That is 3. Minus ko ngayon yung spandrel na maliit na ito. That is 2.8920 divided by 3. Minus the area of this rectangle. That is 20 times 2.11. So, area 2 now is equal to 38.5. Again, can you look closely at this diagram? Paano ko nakuha yung area 1 at saka yung area 2? Using the area of spandrel. Okay, this is geometry. Can we go back to your topic in geometry pag nakalimutan nyo in getting the areas? So, after na nakuha ko yung value ni area 1 at saka ni area 2, pwede ko nang ma-drawing yung moment diagram ko. Again, take note kanina, yung x ko dito is 2.89. Yung area dito is 3.85. Yung area dito ulit is 3.85. So, if I'm going to draw now, yung shear ko from point A to point G, that is the area, itong area 1, that is 38.5. Positive kasi nasa taas. From 0 to 38.5, ano yung magiging itsura ngayon ng curve ko? So, 38.5. Since this is 20 to 0, that is decreasing. Since nasa taas siya, positive decreasing, ang magiging itsura ng curve ko is concave downwards. So, ganyan yung magiging itsura niya. Now, from G to B, that is 0 to 40. Again, increasing siya, pero nasa baba. So, negative increasing. Ang magiging itsura ng curve ko is concave downwards. Ayan. So, nag-0 siya. Now, between B to C, this is a rectangle. The area now is 40 times 3, that is 120. Negative siya kasi nasa baba. So, since dito, straight line siya, pagdating kay moment diagram, magiging diagonal line. Then, the area between C to D is 70 times 2, that is 140. Negative 120 plus 140 is positive 20. That is now a diagonal line ulit. Next, nag-end ako kay 20. Since itong area na to from D to E ay nasa taas, so that is positive. So 20 plus the area of this rectangle is 25 times 2. 20 plus 50 is 70. So again, this is a 0 degree curve. Pag kinonect ko si 20 tsaka si 70, magiging 1 degree curve. Again, nag-end ako kay 70. Since nasa baba yung rectangle, 70 minus this area, 70 minus 35 times 2, that is 0. Again, nag-start ako kay 0, nag-end ako kay 0. So, this is how my shear and moment diagram looks like for illustrative problem number 2. Wala itong problem na to sa notes nyo. I would just like to show to you yung diretsyon na para hindi na kayo nagsusolve or nagsusulat ng madami-daming equations. Again, for this problem, you are required to draw the shear and moment diagram for this cantilever beam. Now, the very first thing you have to do is to determine the reactions for this cantilever. Now, since dito ay fix, meron akong RA. Magzi-zero out yung horizontal reaction dito kasi wala namang horizontal force. Then there is a moment. Here. Meron akong value ni MA. Paano ko masosolve yung value ni RA at ni MA? Now, if I take summation of forces along the y-axis, RA, pataas, pababa ngayon itong distributed load na to. Again, paano kukunin si RA? That is equal to, since pataas si RA, positive, minus, yung area nitong distributed load na to, that is 5 times 2, that is equal to 0. Now, inputting this in your calculator, the value of my RA is equal to 10. Right? Yes. Now, if I take summation of moments at this point, dito kay point A, pag nag-moment ako kay point A, that is counterclockwise C60. So, that ang magiging equation ko dito, minus 60, wala na siyang moment arm kasi this is already a moment. Now, kapag itong distributed load na to na 5 kN per meter, nag-moment kay point A, that is clockwise. So, plus the area of this distributed load is 5 times 2 times the moment arm or the distance. Diba, kapag kinuha ko yung area, ito na yung magiging resultant. So, yung distance ng resultant na to hanggang kay point A is 1 plus 2 plus half nito, 1. 1 plus 2 plus 1 is 4. Right? That is, since si MA ay positive, so plus MA, that is equal to 0. Now, inputting that in your calculator, the value of my MA is equal to 20. 20 kilonewton meter, and the direction is clockwise. Okay? Pag nakuha ko na ngayon yung mga values ng reactions ko, pwede ko nang i-drawing yung shear diagram. Dito kay point A, may pataas na RA. So, that is 10. Susulat ko lang si 10. Since pataas siya, straight line lang yon. Then, from A to B, walang load na along the y-axis. Since walang load, straight line lang yon. Hanggang kay BC. Diniretso ko yon kasi walang load along the y-axis. Now, at point C, doon nag-start yung 5 kN per meter. So, since ito, 10 din ito, pababa yun. So, para makuha ko yung shear between C to D, that is equal to, this is 10. Para makuha ko yung shear from C to D, 10 minus yung area nito, that is 5 times 2, that is equal to 0. Kaya pag nag-drawing ako ng diagram ko ng line between C to D, that is a diagonal line. Take note, dito sa may load diagram, this is a 0 degree curve. Pagdating kay shear, naging 1 degree curve. Okay? Ganyan ang shear diagram ko. Now, if I'm going to draw my moment diagram, ang moment diagram, nakadepende siya dun sa may shear diagram. So, between A to B, ang shear ko is itong rectangle na to. That is 10 times 1, 10. But, now I'm going to draw now the moment diagram. So, at point A, meron akong value ni MA, that is 20 kilonewton meter, and that is clockwise. So, kapag clockwise, pataas yung ating diagram. So, positive, 20 kilonewton meters. Magdodrawing lang ako ng line. After that, mapapansin ninyo, between A to B, meron akong rectangle dito. That is 10 times 1. So, 20 plus 10 times 1 is 30 kilonewtons. Now, I have to connect 20 and 30. Dito sa my shear diagram, this is a 0 degree curve. Pagdating kay moment diagram, that is a 1 degree curve. Okay? Next, nag-end ako kay 30. Dito na rin ako mag-start. Between B to C, that is again a rectangle. So, that is 30 plus 10 times 20 is 30. Then, at point B, merong counterclockwise na 60 kilonewton meter. Again, pag sinabing counterclockwise, pagdating sa moment diagram, that is downwards. So, 30 minus 60 is negative 30 kilonewton meter. Now, between B to C, that is a rectangle. So, negative 30 plus 10 times 2 is negative 10. Iko-connect ko ngayon si negative 30 tsaka si negative 10. Again, dito sa may shear diagram, this is a 0 degree curve. Pagdating kay moment diagram, magiging 1 degree curve. Okay? Dito na tayo kay C to D. Nag-end ako kay negative 10. Kay shear diagram, this is a 1 degree curve. So, pagdating kay moment diagram, this should be a 2 degree curve. Negative 10. Nasa taas to. So, negative 10 plus the area of this triangle, that is equal to 0. So, dapat mag-0 na ako dito. Pero ano yung magiging itsura ng curve ko from C to D? This time, kailangan ko ulit itong diagram na to. Pagpapansinin ninyo kay shear diagram, nag-start siya from 10, then 0. So, that is decreasing. But since nasa taas siya, positive decreasing. Pag positive decreasing, ang magiging itsura ng curve ko is concave downwards. So, ganyan yung magiging itsura ng curve ko. Ladies and gentlemen, ito yung magiging itsura ng shear and moment diagram ko for this additional problem. If you look at your notes, dun sa may post-test, again, wala munang laboratory. Looking at this diagram, or this beam, yung kulay red na circle na to na nakikita nyo, that is an internal hinge. Now, using this diagram or this problem, give to me or show to me the shear and moment diagrams, same through with the reactions. Now, I want to see kung paano nyo na-solve yung mga shear sa bawat points, at saka yung moments sa bawat points. Kung gagamitin ninyo yung areas, show to me paano nyo nakuha yung mga areas na yun. Okay, again, this is an individual activity. No need to follow the format. I just want to see your complete computations. You may use a bond paper, at least bond paper man lang, kahit hindi nyo nasundin yung format.